Hello everyone, today we're going to go over the blind 75 in C++, and today we're working with the problem merge to sorted lists. Now, before we get started, feel free to pause the video if need be. For whenever we are solving these types of problems, we always need to ask ourselves these 4 types of questions. And if you're following along, feel free to pause the video to take some time to write out these comments. For whenever we are breaking down the problem, we need to ask ourselves what the input's going to be, what data structure / algorithm / technique to use, what to do with the data, and finally what our output's going to be. So, to give a breakdown of the problem, you are given the heads of 2 sorted linked lists, list 1 and list 2. Already self-explanatory. You can also look at the parameters up here to justify. Merge the 2 lists in one sorted list. So, we got to do that. The list should be made by splicing together the nodes of the first 2 lists. And then return the head of the merged linked list. Okay, well, it looks like we got to merge the 2 lists in one sorted list. And we found a way, literally just from the question, to be able to break it down based on keywords and knowing how to organize it. So it looks like, in particular, that we are just merging all of the linked lists together, like we have list 1, list 2, all of them being sorted and merged accordingly. If we have an empty list, we just have an empty list return. And then if we have an empty list and 0, so we have 0 right here, and the numbers can go from negative 100 to 100 in value for each node, and the number of nodes in both lists is in the range of 0 and 50, the node value. Interesting. And then we have both list 1 and list 2 are sorted in non-decreasing order. Alright, so we already have that. So luckily, what we will do, because of how easy it was to be able to dissect the problem, is that we're going to use merge algorithm of merge sort, where, as the name explains, what we're doing is that we will be creating an algorithm to merge both of the linked lists accordingly, and then we will be sorting them. Ultimately, we can sort them first and merge them all together. Well, since we already have 2 sorted linked lists to begin with. And what we will do is that we're just going to check while we are scanning through them. So the steps for us to be able to operate on this are the following. Step 1, we need to initialize a new head and current pointer. And step 2, while both list 1 and list 2 are not null, if list 1's value is less than list 2's value, we will add list 1's node to the current list and move list 1 forward. Otherwise, we will add list 2's node to the current list and move list 2 forward. Then, while we are doing this inside the while loop, we're going to move the current pointer forward after adding the node, since everything is already sorted, and that helps us a lot. And after exiting the loop, if there are any remaining nodes in either list 1 or list 2, we're going to add them to the current list. And 5, we're going to return the new list from the head. Okay, just to give a breakdown over exactly how we're going to go about this. Just going to write this out accordingly. Step 1, step 2, step 3, step 4, step 5. I'm just going to clean up all this for you folks. And step 1, the way how it's going to look about, is that we are going to create our node dummy equal the new list node -1. The reason why is that this is just how we initialize it. And list node current equals dummy. Then list 2, we're going to create a while loop while list 1 doesn't equal null, and list 2 doesn't equal null. This would be A and then B. So A will be if list 1's value is less than list 2's value. If list 1 value is less than list 2 value, we're going to add list 1's node to the current list. So current next will be list 1 and move list 1 forward. So list 1 is going to be list 1 of next. And the reason why we do this, we can even look up here and leverage off of the list node data structure that we are also given too, which is why we have next to begin with. And then we're just utilizing that along the way. And then else, in the other case, we're just going to do the same thing for 2, basically. Current next list 2, and then list 2 is equal to list 2 next. We add the current node to list 2 based on this condition that we have up here of list 1's value being less than list 2's value, and if not, then we are going to add list 2's value to the current list. And then for step 3, inside of our while loop, we're going to move the current pointer forward and add the next node. So current is equal to current next. Just want to be sure I got this. Okay. It should be in here. Just want to be sure if we have it all set up in place. Yep, it's in the while loop. And then for step 4, after exiting the loop, if there are any nodes remaining in list 1 or 2, we're going to add them to the current list. So if list 1 is not null, we're just checking for any outliers. We're going to move current next because we assume in the while loop we've scanned for everything. And this is just for safe measure. The current next equals list 1. And then else if list 2 doesn't equal null, then we're going to have our current next list 2. And then finally, we are going to return the head of our dummy. So return dummy of next, because we stored everything inside the head of our dummy linked list. So let me just double check to see if we have everything that's right. If else, yes, we do. Okay, let's just double check. All right, it passes all the test cases and submitting. Okay, so now just to give a rundown on the spacing and time complexity for our following solution is that the time complexity is O of n plus m, where n and m are the lengths of the two lists. And this is because in the worst case scenario, we have to visit every node in both lists once when merging. While the space complexity is O of 1 because we only initialize a fixed number of pointers and do not use any auxiliary space that scales with the size of the input. And so yes, this was merged to sorted lists. Thanks again for taking time to watch this. If you found this helpful, feel free to like and subscribe. And if you have any other questions, feel free to put in the comment section. And as always, take care. Cheers. Bye-bye.